What's up, Jason here from Unity3D.College. Today we're going to talk about pooling systems, and we're going to go pretty deep. A pooling system allows you to reuse your objects, which gives a really big performance increase, especially on mobile devices and VR platforms. You really want to avoid generating garbage, which is exactly what this pooling system stuff will allow you to, well, avoid doing. So let's get started. We're going to go over a couple different types of pooling systems. We'll start with something relatively tightly coupled and then move in a more generic fashion as we kind of go through these things. But to begin, I want to show a system with no pooling at all. So our first sample, we have just this spaceship here, just a simple spaceship grabbed off the asset store, and this has a blaster on it. This blaster is just an empty game object with this blaster script, and if we go to the scene view and hit F right there with it selected, see it's just kind of set up to be right around where this wing is so that our blaster shots will spawn right there. So let's hit play, watch it, and then we'll take a look at the code. There we go. Any second now. There we go. We got some shots coming out. If you look here at the refire rate, you'll see that it's set to 0.4. So we're getting we're about 2 a second, a little bit faster than that though. And this is the prefab that it's spawning, this blaster shot no pooling, which you see down here in the folder. So let's open up the script. All right, this is somewhat important because all of these examples use very similar code for the firing and refiring part. So let's just look at this kind of in detail and see how it works because it's going to be reused all the way across. We have first a serialized field for this blaster shot prefab. Now this is referencing a very specific blaster shot for this example. There's 4 different examples here. They each have a slightly different name just so that there are no collisions and that everything's kind of clean. So we've got our blaster shot prefab right here. We have a refresh or refire rate. Remember, it's set to 0.4 in the editor, but it's set to 2 here as a default. Serialized field allows us to edit this private variable in the editor though. And then we have another private float here for fire timer. This one is not editor inspectable or editable, but it is getting counted up in update. So if you look here on line 15 in update, we increment it by delta time. If it passes the refire rate, so if it gets to over, I guess, 0.04 in this actual example, then we set the timer back to 0 and call fire. It's just a very simple system to call fire every whatever time this is set to, whatever that interval is. So then in our fire method, very simple. We are calling instantiate, so it's just game object.instantiate. We're passing in our blaster shot. We give it our position and our rotation. So this spawns the shot there. Let's go look at that blaster shot script. So this one you see has a move speed just hard-coded at 30, a lifetime, a max lifetime set to 5 seconds, and in on enable we reset that lifetime to 0. Just, hey, this thing has not been alive. Doesn't matter so much for this non-pooled one, but in the pooled ones it makes more sense. And then in update, we move this thing forward using transform.translate and giving it vector3.forward, move speed, and delta time. This just makes it go along with the frame rate of the game. And then we increment the lifetime, and if it gets to be too old, so it gets over that 5 seconds, we destroy it. Nothing complicated at all. And you see here that it looks like we have just 10 shots, but if I select one, you see it's actually moving up and eventually getting destroyed. And these are just new ones that are getting created and added on. So every time we fire a shot, we create a new shot. Every time a shot gets to 5 seconds old, we destroy it. Of course, if we hit something with one of these shots, it would normally destroy as well. Now, before I talk about how to fix the problem, I want to show you what the actual problem is. So with this still running, I'm going to go to Window, and then I believe it's moved to Analysis, and then Profiler. Things have been moving a lot lately. But here we go. We've got the Profiler window open, and I'm on the CPU usage part. In fact, if I drag this up, your window may look a little bit bigger than that. It may be off floating. I've just got it docked right down here. So we can see the CPU usage is going. I have scripts and garbage collector showing only. If you click on these, you can toggle them on and off. Scripts and garbage collector are really the only things I'm worried about right now though. So I'm going to hit current to just get current data right there, and we should see it right down in here. So if I expand this out in our player loop, you see this GC alloc. That is the garbage collection allocations that have happened. So this is allocations of memory that are going to need to be cleaned up by the garbage collector later. And if I sort by this, you can see where this is coming from. So part of it is in this send mouse events. This is probably some debugging stuff in the editor. because we're not doing anything with the mouse. And that's one thing to watch out for. The profiler and the editor will generate some garbage here, so you need to look at the stuff that's specific to your game. In our case, though, it should be, well, here, let's just click on a point and see if we can find a good spot. Where's a point where a lot of garbage is? There it is. So where these 40s and 80s are happening, and here I'm just dragging this white bar until I see the bigger spikes. Again, because those other ones are just the editor. But if I expand out the script run behavior update and expand this and expand that, you see that the garbage is actually generated in this instantiate call. And it's when we create this new object that the memory is allocated, garbage is generated, and it then has to be cleaned up when the object is destroyed. Again, on a fast computer in Windows or Mac or even on Linux, it's not really going to be an issue. It's not going to make a big difference at all if we're allocating a little bit of RAM here and cleaning it up. If we're on mobile, though, it's going to make a huge difference, and if we're on VR, it can even make people sick, because you can end up losing frames. Now, if you're playing, again, a game on a flat screen running at 30 frames a second or 60 frames a second, if you drop a frame, doesn't matter. If you drop 10 frames, your frame rate drops from 60 to 30 for a quarter of a second, it's probably not going to be noticeable unless you're in a really twitchy shooter or something. So it's a much bigger deal on these other platforms, but it is important. And you can go overboard. You can be generating so much garbage that it does become a problem on a Windows system. So just try to minimize this as much as possible and use these pooling systems for that. So with all that explanation there and the reason for why you would want to use pooling, let's see how we would set this up using a pooling system instead. Now here we have a simple pooling example. Again, we have a spaceship. Expand that out. We have a blaster. The blaster is a little bit different, though. We don't have a reference to a prefab. We just have a refire rate, and here I've turned it down to 0.02, so this one will shoot a little bit faster. And then we also have in our scene this blaster shot pool, and I noted that it's hard-coded because, you'll see, this one is relatively hard-coded for how it works. And this one does take a prefab for a blaster shot, which is just this other blaster shot. Again, very similar, just a slightly different class name that we're using here. So let's hit play, watch it in action, and then we'll dive into how it's actually working. So there we go, we're playing, and here I've also added an animation, so this thing will just kind of go up and down. But watch the shots here. So you see the shots, and you may notice something there. If you're paying close attention, some of them are graying out. So if I select one right here, let's just watch. Eventually you'll see this is going to get disabled. Oh, it may have gone so fast I didn't even see it. There you go. Disabled and then re-enabled. So what's happening? Well, let's go to the scene view and hit F. And just, oh, here, I'll zoom out. Let's watch one of these shots. So there goes the shot. It's flying all the way over there, and you see it reappeared back over there. It's because it's being reused. Instead of getting destroyed when it hits the end, it's actually getting disabled, kind of shoved back into a place. That place is our pool. And then pulled back from there when we need to use it. So let's stop playing and take a look at the code and see how this all works. Well, first thing I want to do is just open up the blaster. We've already looked at the blaster, so let's see what this difference is here. Here we have a refire rate and a fire time. All of this is exactly the same. Same old boring boilerplate fire refresh stuff. But then in our fire method, we're doing things a little bit different. Instead of instantiating something, we're calling blastershotpool.instance.get. And then that's returning back a blaster shot. You can see that right here if I mouse over it. Then we're setting the transform position and rotation to match our blaster and setting the game object to true. So here, instead of instantiating a new shot, we're telling this pool in its singleton instance to give us the shot, and then we're putting it where we want and turning it on. Let's go into our blaster shot pool now. Alright, so this is a very simple basic pooling system. We have a mono behavior here with our pool class name. And then here we have a prefab for the prefab that we want to instantiate with our pool. Again, this one's very tightly coupled. We'll get into more generic ones soon. But this one only takes a blaster shot. Then we have a queue of blaster shots. A queue is just a first in, first out collection. So you put things in one side with an in queue, and they eventually pop out with DQ. Whatever the thing you put in first is the thing that you'll get out first. So if I put in two things, I'll get out the first thing. You get the idea. I've done a whole video on these, so if you're interested, just go search for it, or I might link it too. Beyond that, we have a very basic singleton setup. So This video is not about singletons. I didn't want to dive too much into it, so I just kept it as basic as possible. We have a public static blaster pool, shot pool, so it matches, named instance with a public getter, because this is public, and a private setter, so nothing else can set the instance. In Awake, we set the instance to this. Again, this would not survive across a multi-level game or something like that, so you need to set it up to actually persist or don't destroy on load or something else. You need to come up with a slightly better singleton, but I didn't want to go too much into that. Again, not the focus of the video. This right here is the focus of the video, though, this get method. So this is what we were calling from the blaster pool right here, this blaster shot pool.instance.get. And that was, oh, I lost my place already. Let's go right back to it. So this is looking at this blaster shots queue and checking to see if it's empty. First time through, it's actually going to be empty because we're not pre-filling this. If it is empty, we call add shots, and then we eventually dequeue. So we get whatever this shot is in there. So if there are no shots in there, we add one, and then we pull one out. So eventually, maybe for the first, whatever this is, maybe 10 shots that we were shooting, we were actually instantiating a new shot each time. We're just never destroying them, so they're getting reused. Now our add shots method, see, it just takes a count and loops through and instantiates that many shots. So we get a blaster shot from the prefab, we set it to not active, and we in-queue it. This is how we add it to that queue. Now you might wonder why we're taking a count here if we're always passing in a 1. That's because sometimes we want to do things like pre-warm these. So we may do something like on enable and just say add shots 10. Or we can do this in a start or something. And the reason for that is once we know how many of the objects we generally need and we have a really good idea, maybe we know that our game requires about 50 shots max on screen at a time, we can pre-initialize all of those right at the startup so that they don't have to be created at runtime. It's faster, a little bit more performant, just to avoid some hitching, but it does eat up extra memory. So we don't really want to do that until we know a good idea of how many we need, and then we do want to have the ability to grow the pool beyond that if we guess wrong. In this case, we're just not guessing because we really don't know, because let's be honest, it's not a real game. It's a spaceship going up and down shooting off some shots. So that's essentially how the add shots works, but then there's one more part right down here, this return to pool. So spawning things from a pool and putting them in a queue and pulling them out of that queue is really cool and all, but it doesn't do anything if we never put them back in when they're done. If we just destroy the objects when they finish, then it's not going to work. We need to return them to the pool. So let's see where this is called from. In fact, to do that, I can just select it and in Visual Studio, hit Shift F12 to find the reference. And that's in our blaster shot script. So this was the script that's on this blaster shot prefab that we're spawning. Let's look at it. So the blaster shot, again, same exact stuff. Except here the lifetime actually matters because on enable we're setting it back to 0. So remember, we're disabling the object when it gets to dead time, and then we're enabling it when we need to pull it back out. So in our update here, if we reach the max lifetime, instead of destroying the game object like we did in the previous one, this one right here, we just destroyed game object. Here we just call blaster shot pool.instance.return to pool. That puts it to not active, resetting that timer when we re-enable it and set it to active again, and then re-enqueues it. So pretty simple, but there are some issues here. The biggest issue is that this is super tightly coupled. This pool only works with blaster shots. The blaster shots need to know exactly about that pool. Pool has to be there. And if we need to do it for another thing, we basically have to copy and paste this whole thing. So if I wanted to make a missile pool or something like that, I'd have to copy this whole thing, make a missile pool, change this to missile something, missile pool instance. You get the idea. There's a lot of copy and pasting and just kind of messiness that comes along with this. Now, if you're only going to pull one thing, whatever, totally fine. But once you need to pull a second type of thing, it's a lot better to move into one of these more generic options that I'm going to show you. This next pooling system is a whole lot more generic. In fact, it's probably the most generic pooling system I can come up with. And let's take a look real quick. We've got a space fighter here, and I've got 2 blasters. And if you look here, this blaster is a blaster game object pooled. And we have a game object pool that we're assigning, and then a 0.5 refire rate, because we've got to mix it up every time, right? Then down here we have a game object pool. Just select that, and you'll see that we have a reference to a prefab for this blaster shot game object pooled. And I'm going to clear this reference real quick. Notice that the prefab type here is game object. That's why this is a game object pool. It takes any game object and will pool that game object. So we don't care what type of object it is. We just care that it is a game object so we can pool it. Let's hit play, watch it, and then take a look at how this thing works. There we go. So it's firing 2 shots from this one pool. And you see the shots are there. And notice that they're kind of disabling in pairs. And that's just a side effect of them spawning together. 2 spawn at a time. Those 2 happen to die at the same time, so they're enabling and disabling. If we were hitting targets and stuff along the way, the order that these are enabling and disabling would be totally different, because some would go past, some would disable when they bumped into things. I think you get the idea, though. So there we go. We got 2 shots firing. They're using this one pool. If I select the 2 blasters, you see if I click on these, they both go to that same pool. So they're both sharing that pool as a resource for blaster shots. Oh, let's look at the blaster first. The blaster here has the same refire rate stuff, the same fire code. That's all exactly the same. One difference, though, is the serialized field for the game object pool. That was the one that you saw in the inspector there, right here, this game object pool that's assigned. And that is used right down here in fire. So when we fire, we just say, hey, game object pool, give us the shot, and we do exactly the same stuff. So here, the only real difference that you're noticing in this blaster shot, or this blaster versus the other one, is that we don't have a hard-coded pool. We're now assigning the pool to the object. Some situations this could work fine. Some situations, maybe not. Just really depends on how the game is set up. In this case, though, as long as we have a way to set this pool, we're good. So it may or may not be done through an inspector field like this. It could be done some other way. We just need a reference to a pool that we can use to create our objects and keep track of them. So let's see. We've got our pool there. Let's see how that pool is actually working. We'll open this script up. And again, you see we have a prefab. This time it's just named prefab, and it's a game object, though, instead of a specific type. And we have the same singleton pattern right there, this instance and instance. And we have a queue. Now it's called objects because it could be anything. This could be a particle system. It could be an empty game object. It could just be a primitive. Whatever the thing is, it doesn't necessarily have to be, a blaster shot or a missile or something. In our get, we do the exact same code. Check to see if there are none. If there are none, we add one and dequeue it. And then in our return to pool, we do, basically the same stuff. You see, there's really no difference all around, except for one thing. If we're using game objects, we need a way to get these things back into the pool, right? We have our general game object, and we want it to go back to the pool when it gets disabled or when it's going to be destroyed or whatever it is. So the way that I like to do this, and this is kind of an optional add-on here, you could manage it some other way, but I think that this system works pretty well, is I like to use an interface, and I'll add the interface to one of the components on the game object. So it could be a specific component just for handling pooling. It could be a component specific to the type of thing it is. Like this could be on a blaster shot. In fact, in this case it is. Or it could be its own total separate script. But I like to use an interface for it. And in add objects, what you'll see what I'm doing is we're calling get component to get this iGame object pooled interface, and we're setting the pool to this. Let's go look at that interface. Right here you'll see that the interface is actually extremely simple. It has a pool on it for game object pool with a getter and setter. That's it. So you might wonder, well, how the hell are we using this? What does it do? Well, let's take a look again at the project. So if we go back over here, we look at our game object pool and we look at the prefab that we're spawning. It's this. So if I click on this and let's just hit open prefab, we have this blaster shot game object pooled script on it. Let's open that up. And that's the one that we were actually in here. The interface is just at the bottom of it. Normally I put the interfaces in their own files, but in a simple thing like this, it makes sense to just keep it there. If we scroll up here to see that we are implementing that interface, the iGame object pooled, and right here you can see the implementation of that. So it could just be a getter and setter. It could be as simple as this. Let's, in fact, Let's comment that out. We could do something as simple as public game object pool with a get and a set. That could be it. What I've done here instead, though, was give it a backing field, this private one, and then just make it so that it can only be set once. So in our check in the setter here, we're saying, hey, if the pool is null, set it to the value. Otherwise, throw an exception because we're doing something wrong. It's not being used as it's intended. The pool should never change. Once an object is added into a pool, it should stay in that pool indefinitely. It shouldn't ever like go to a different pool or have its pool value be set to null or something like that. So this is just here as an extra check. Then in our update, when things expire right here, we have this pool that we've set right there, and we just call return to pool and we pass in our game object and we're done. So here again, it's a nice simple little way to add the functionality on top of a game object without having to add too much more. We can of course get by without this, but then we need to come up with another way to return the object to the pool, which could be like a manager system that's managing the life cycle of these things and pushing them back into the pool. But I generally prefer a nice simple system like this so that things can just kind of disable themselves or expire or whatever they're going to do in their code and then return themselves. So again, this system works pretty well. It's not the one that I use most of the time though. In fact, that one's coming up next. So let's get to that. All right, this pooling system is using generics. If you haven't used generics, don't worry. They're not really complicated. They seem a lot more complicated than they are. It'll be pretty simple, though, I think, once we go through the whole system. So here you see we've got the ship shooting 3 shots at a time now, and lots of shots are firing off, and they're just getting reused, right? None of them are getting destroyed. It's all reused and pooled. Fun stuff. So let's stop playing, take a look at how this thing differs and what the benefits are here. So here we've got 3 blasters. These have a blaster with generics on them. Blaster with generics, blaster with generics. And then we have a shot pool. So our shot pool, if you look here, takes a prefab for this blaster shot with generic pool object. And that's, again, same thing, just a slightly different script on it for the 4 different folders that we've got going on here. So let's take a look at the blaster first, just like before. At our blaster with generics. Again, we have the same refire, all exactly the same. And here in our fire method, you see this kind of looks a little bit more like the first version, right? We had the blaster shot pool.instance.get that just returned back a blaster shot pool. You might think like, hey, this is very similar to that one. What the hell? Like, is this the same? Nope, it's totally different. Let's look. So if I go to definition there, you see that this shot pool is actually totally empty. There's nothing here. It's a generic object pool of type blaster shot generic pool. Great name, right? So this is taking advantage of generics. But the benefit here is that we're going to get a lot of the close coupling that you see in the other one without the copy paste rewriting code. And I say it's close coupling. I mean, it's going to be easy to tell what's referencing what, and we don't have to use so many editor specific references for stuff. Now, if you're working heavily with designers who are constantly changing these things, maybe not the best solution for you. But if you work like I do and it's mostly in code and you prefer a lot of things to be in code where it makes sense, then this system, like I said, it's perfect for me. I find it the easiest to figure out exactly what the thing is, what the pool is, what I'm grabbing. So let's stop blabbing though and just kind of get into how it actually works. So if I go to the shot pool, that was this. We need to look at the base class here, this generic object pooled. And remember, we're using the type blaster shot generic pooled. So here we go. First thing to notice, this is an abstract class. That just means that we cannot instantiate it. You cannot create a new generic object pool. It has to be a subclass like our shot pool that we just saw. We also can't just add this script directly to a component or a game object as a component. It won't work because it's abstract. And that's intentional because this is not meant to do anything without defining what this T is right here. And this is how the generics work. So we create a class and then we give it the little less than, greater than brackets there. And then we put something in here. And T is a pretty usual convention just because it's short for type. But this could be named pretty much anything. I could name this like T to pool or T pool or whatever, or I could name it J because my name is Jason. It doesn't really matter, but T is very much a convention. If you start to see multiple things though, like maybe you have one that's like T and K or something, it just means you needed two different generic types and you have to give them different names. Don't go with T1 and T2 though. If you do run into this case where you need multiple generics, just name them properly. In this case, T is good. So you might wonder what the hell that all means. Well, let's keep going. So we have generic object pool of type T, and it's a mono behavior. And then we have this where T component. So what this is saying is that T, whatever this type is here, must be a component. This part right here, this where T component means whatever T is, it must be a component. We can't do it without it being a component. In fact, I can show that. So if we save this and we go over to where's our pool? Which pool was it? There, go back. There. If we go right here and we change this to like int, we're going to have an error. Let's say, hey, int cannot be used. There is no boxing conversion from int to Unity engine.component. Because the type here must be a component. Luckily, our blaster shot generic pooled is a mono behavior, which is a component, so we're good to go there. Well, let's look at this class while we're in here. Same exact stuff, nothing different. Right here is the only difference. We call shotpool.instance.return to pool. Again, it feels tightly coupled, but it's a lot simpler and a lot cleaner, and I just really prefer this over passing in a pool or assigning a pool. I know that my shots all care about the shot pool. They're not really coming from other pools. And this is the case a lot of the time when I'm making these pools. They're usually one type of thing in that pool. It's not changing. I don't need to adjust it at all. So setting them up like this works. And I usually don't end up with too many pools. It's another thing to really point out. In a game, I may have one pool for the whole thing. I could have 10, but I'm never going to have hundreds of these things that I need to manage. At least not in any project that I've worked on. There's probably some edge case project where it makes sense. But in general, there aren't that many things that I want to instantiate a bunch of and remove and add. So let's look some more. So we've got our generic object pool. And we've got that T. And we know that T is a component. So then here, our generic object pool instance also needs to have this T. Because we want to find the instance for this. In fact, this right here, along with the awake method right there, is how you can do a very simple generic singleton. So here we can, if we just had that and this, we'd have a very simple generic singleton that we could use and then call the instance part on it. Because remember, if we look at our shot pool is called with shotpool.instance, and it's getting it because right here in the base class, we know that we have it. Then we have a queue of type T, so whatever the type is that we're using there, in this case it's that blaster shot. And then in our get method, we're returning T. So again, this is going to return the blaster shot, the one that's right here. It's going to return whatever this is. So if you think of it like this right here is essentially what you see. Oops, let's save that. What this is going to be like. It's going to be like that when we use this as our type for the generic. So then we're able to get it from the queue, just dequeue it just like normal. And we're able to return it to the pool the same way. We just use the same T here for the type of object to return. Since T matches there and there, we can return it. And then in add objects, same exact stuff. So nothing really different except for the fact that now with this very, very basic generic pool, you can ignore this other stuff down below there, by the way. Nothing important there. But with the others, with this system right here, we can create these other pools very, very easily. We just say, hey, here's the pool name, here's the type, done. Right? That's it. We have a pool. It's ready to use. It's reusable to a degree. I mean, it's the code underneath there is reusable because all we need is this little chunk right there. Anyway, thanks for watching. Don't forget to like, subscribe, share with all your friends and that stuff, and have a great day.